So, as promised at the end of the previous video, this is going to be a horrible example, which includes a whole lot of things which are not particularly lovely as we go through. If you want to have a go, you want to pause the video, have a go at it, see how you get on, and then use my video as a help. Do it that way. That might be a really good way to kind of learn from my working and see what comes out. Let's set off then. So the first thing we're going to do is just rearrange. So let's rearrange. Let's take the 1 off both sides. And let's divide both sides by 5. So it's the very first step is to divide everything. You can either write that as 3/5 or as 0.6. Don't mind which one you've done. Positive, so I haven't made it the worst thing you could see, but it's positive. So we can do x equals sine to the -1 of 3/5. And that will, when we come to do our cast, that'll be our RA, relative acute angle as well. But be careful that your calculator is in radians mode, because if we look up here, this is in radians. So make sure everything's in radians mode when you're working through this, because otherwise you'll get a nonsensical answer at the end compared to what we're working in. And I'm going to put a little rad there because I'm not working in pies, just to make it clear that's an angle in radians. I'm just writing rad in just to remind me. Graph approach. On my graph approach, I want a nice sine graph. And we're talking about 3/5 or 0.6. So that's about there, say. So there's my two angles. The first one I've got here is 0.64 radians. The middle here is pi. We're coming along by 0.64 radians. So it's the same as coming back from pi. So it's pi, take away 0.6435. You can pop that in calculator to work that out. Which rounds nicely to 2.50 radians. On our cast diagram, how does that look? Well, it's sine and it's all. So that's our relative acute angle, or this one here. And this sine one, well, we're starting at pi there and taking away our relative acute angle, which matches what we've got here. So whether you cast a graph, we got to there. That gives us two values. Now, this is where things become a little bit more nasty again. Just quickly, it might be worth, and I sometimes do this just to give myself a clue when I'm working with decimal radians and radians with pies, it can be handy to convert this to just a decimal, just so we can see how big or small we are relative to what's going on. So 6.28 and minus 6.28 is the region that's between -2 pi and 2 pi. So just to help us further down. Working with that, we're going to be adding on lots of 2 pi to this. Now, obviously, if we've got something bigger than 0 and we add 2 pi, we're going to be bigger than 2 pi. So we're not going to get any more angles by adding 2 pi to this, but we could subtract 2 pi to get some negative angles which fit in this part. So let's try doing that. So sine repeats every 2 pi radians. So, as I say, adding on 2 pi to this, you can give it a go, but you'll end up with something that's bigger than 6.28, so it wouldn't be in the range. But we can do 0.6435, take away 2 pi. Now, in the previous videos, I was doing lots of work with pies. Here we've got decimals, so we'll just plug that into the calculator. That gets us -5.64 radians. It's worth checking, but that is still bigger than -6.28, so we're fine. And it's still within range. The other one's 2.50, take away 2 pi radians, gets us -3.7850 something, which rounds to -3.79 radians. So all our work is done. You could try taking another minus, or taking another 2 pi off these. You'll find immediately you're over the minus 6.28 though. So what are our answers? Let's summarize our answers. These are all in radians. We have 0.64, just keep everything to 2 decimal places, 64 radians, 2.5 radians, minus 3.79 radians, and minus 5.64 radians. And those are our final 4 answers to this question. So lots going on there, lots of different things getting tied in. Don't panic if that seems really, really difficult. As kind of bigged up to be, that is a horrible example, bringing in a whole lot of different bits of knowledge that we've studied over the last few days. But some of the hardest questions on the ones that I've posted will just about get into the territory of this example, where you've got ranges to worry about and rearranging, and you're working with some radians in there. So have a go at some of those, and then task number 3 is going to take a slightly different step again, but bringing in lots of the different facts that we have been learning.